Welcome again to Dr. Lloyd's Organic Chemistry Podcast, my scribblecast on organic chemistry lectures, and where we take up organic chemistry problems. In this case, we're looking at a homework problem where we had to determine the Lewis structure and formal charge for each non-hydrogen atom in the molecule SCN-. It's called thiocyanate. And in class, you were told that there were potentially three solutions for this structure, three acceptable Lewis structures that could be assigned for the molecule SCN-. So what we're going to do is we're going to begin with our procedure for finding the Lewis structure, and once we're done these structures, we'll take a look at the formal charges. Now, the first thing we're going to do, as always, is determine the total number of valence electrons. And let me just say, this total number of valence electrons applies to all three structures. Secondly, you should note that the linkage pattern, S to C to N, cannot be changed. That's fixed. So all the structures will have the same arrangement of atoms. Total number of valence electrons. Valence electrons, and we'll just put a negative charge there, equals. How many valence electrons does sulfur have? Well, we go to periodic table and we look at sulfur, we find out it's right below oxygen. Same group as oxygen, it'll have the same number of valence electrons. Sulfur has 6. Carbon from the periodic table has 4 valence electrons, and nitrogen has 5 valence electrons. We also must add 1 electron for the negative charge. And so we have a total of 16 electrons. Okay, so now what we're going to do to draw a Lewis structure, we're going to start over here and give sulfur 1, 2, 3, 4, 5, 6. We're going to give carbon 4. 1, 2, 3, 4. And we'll give nitrogen 5. 2, 3, 4, 5. All right. Now we have to remember that we have to add that extra electron. We put the extra electron here in the total number of valence electrons. Well, you have to give the extra electron. And we could put it anywhere and it would work. We would get a solvable structure. But I'm going to use some intuition here. I'm going to say, well, who's the most electronegative atom? If you memorized your list, fluorine's more electronegative than oxygen, is more electronegative than nitrogen and chlorine. Nitrogen is more electronegative than carbon and sulfur, so let's give it to nitrogen. So I give an extra electron to nitrogen. Now we start sharing electrons till we get 8 electrons around every atom. Okay, so we can do this very nicely here. I can, for example, go with the sulfur and say I'm going to join those 2 electrons. Sulfur has 2, 4, 6, 7. I'm going to join these 2. Okay. 2, 4, 6, 8. Sulfur's happy. Now, what can I do? Let's see. We can start sharing with nitrogen. That would be the first most obvious thing we could do. And if I start sharing with nitrogen, carbon and nitrogen both get 1. Now carbon's got 2, 4, 6, 7. Nitrogen has 7, so join it up again. What do I end up with here? It looks like this. Now let's repeat this again with the exact same configuration to show you could have generated a different structure. How? Well, let's put our sulfur down, give it its 6 electrons. I'm going to show you can get all 3 structures without changing the arrangement. You might be able to get a better lead on it if you moved that free electron around, but you don't have to. You can get all 3 structures using your knowledge of bonding and Lewis structures, even if you put the electron in the same place every time. And where did we put it last time? We put it on nitrogen. So I'll do that again. And we're set to go. I'm going to do the same thing. I'm going to start linking up with sulfur. I'll link up with sulfur again. Now this time, I'm going to do something different. What are you going to do that's different? Well, if I look at this, what I've done so far, I did exactly the same thing I did. I started with sulfur, and I've got 2, 4, 6, 8. And then I count a carbon, and I say carbon's got 2, 4, 6. Carbon needs 2 more. And I started sharing from nitrogen, but I didn't have to. I could have said, well, I'm going to have these 2 electrons right here dump into carbon. If I do that, I'm creating, those 2 electrons are coming in what is called a dative or coordinate bond. And we defined that already. And so sulfur still can count those 2, 2, 4, 6, 8. And carbon's happy, 2, 4, 6, 8. So now that carbon's happy, he doesn't have to share with nitrogen, but nitrogen's short 2 electrons. So carbon can share these 2 datively, just the way sulfur did, and dump them in. And if you do that, sulfur only has 1 lone pair, and he's made 1, 2, 3 bonds to carbon. And then this dative bond from carbon to nitrogen is a single bond, and all these lone pairs here, I'll circle those lone pairs in red, just so you can see them. Okay, so this lone pair, they haven't been shared with anything. They're still lone pairs. So this is what we've created. All right. Well, as you can imagine, if we do the exact same thing again, and I am running out of space, so I may have this a little scrunched. I hope not. I'll try to do it. If I have to, I'll erase it. So sulfur has its 6 electrons. Carbon has its 4. And nitrogen has 5. This time, to get a different third structure, I'm going to start with nitrogen. And when I join up nitrogen with a double bond, I see nitrogen's happy now, 2, 4, 6, 8. Carbon only has 2, 4, 6. Nitrogen could dump in one of its lone pairs in a dative and make 3 bonds there to make carbon happy. So nitrogen is 2, 4, 6, 8. Count carbons now. 2, 4, 6, 8. Sulfur needs 2 electrons. Carbon doesn't want to share them, but he can datively donate 2 electrons to the sulfur. If we do that, we get sulfur with 3 electrons around it. 3 lone pairs. Carbon and the triple bond to nitrogen. And this guy right here, that guy up there, is the only lone pair of nitrogen. And if you see, the bonding arrangements are different. In the one on the left, we have 2 double bonds. In the structure in the middle, we have a triple bond to sulfur, single to nitrogen. And we reverse that in the structure on the right. Sulfur has a single bond, while nitrogen has a triple bond. In each case, we can do a formal charge. Formal charge for sulfur, formal charge for carbon, formal charge for nitrogen. And if we do that, formal charge for sulfur, in this case, sulfur has 6 valence electrons. That's from the periodic table. You count all of the lone pairs, and you assume equal sharing for each bond. So in each bond, sulfur will get 1, carbon will get 1. So sulfur has 2, 4 in lone pairs, 5, 6, 2 from bonds. So 6 minus 6 equals 0. That's again 2, 4 from the lone pairs, another 2 from the bonds, 1 from each bond, makes a total of 6. Carbon has 4 valence electrons. No lone pairs, only bonding electrons. We count 1 for each bond. 4 minus 4 equals 0. Nitrogen has 5 valence electrons. In our structure, nitrogen has 2 lone pairs, so that's 4. 1 for each bond, 5, 6. 5 minus 6 is minus 1. The net charge equals minus 1. Now, several things you do, always to confirm your structure. Make sure in the Lewis structure the total number of electrons is 16, or you've done something wrong. 2, 4, 6, 8, 10, 12, 14, 16. Also, always check to make sure you got only 8 electrons around each atom. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Lastly, make sure your formal charge that the net charge, the addition of all the charges, equals the charge on the molecule given. Minus 1, minus 1. So we've worked things out. Let's do it again for this second middle structure. Formal charge sulfur, formal charge carbon, formal charge nitrogen. Formal charge sulfur, in this case, sulfur has 6 valence electrons. We count the electrons with sulfur. There's 1 lone pair, that's 2. There's 3 bonds. Sulfur gets 1 for each bond. 2 plus 1, 3, 4, 5. 6 minus 5 plus 1. Ooh. Carbon, formal charge on carbon. We have valency from the periodic tables 4. Count the electrons in bond. We assume equal sharing. 1 electron for each bond. 4 minus 4 equals 0. And formal charge of nitrogen. Nitrogen has 5 valence electrons from the periodic table. We count the electrons in the structure. Nitrogen has 3 lone pairs. That's 6. It gets 1 electron from the bond. That's 7. 5 minus 7 equals minus 2. Ooh, in this structure, nitrogen has a minus 2 charge. Add that up, and my net charge plus 1 plus 0 plus negative 2 equals minus 1. The net charge works. Again, check your structure. Are there more than 8 electrons around any atom? 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Lewis structures need filled octets. That's never less than 8, never more than 8, unless there's the exceptions that we learned about when we did the H2SO4 problem. Third row has accessible 3D levels. All have 8 electrons. Do we have 16 altogether? 2, 4, 6, 8, 10, 12, 14, 16. Yes, check. Net charge, minus 1. Check. Everything's check, check. So as far as Lewis structure goes, the middle structure is as good as the structure on the left. Let's do the last one. Formal charge sulfur, formal charge carbon, and formal charge nitrogen. Formal charge sulfur, we have 6 minus, sulfur has 3 lone pairs, that's 2, 4, 6. You get 1 for the bond. 6 minus 7 equals minus 1. Formal charge carbon, carbon has 4 valence electrons taken from the periodic table. No lone pairs, 1 for each bond. 4 minus 4 equals 0. And finally, a nitrogen. We have 5 valence electrons from the periodic table, 1 lone pair, 3 bonds. 5 minus 5 equals 0. That is, the lone pair gives you 2, each bond gives you 1, so that's 2, 3, 4, 5. 5 minus 5 is 0. Net charge in this case, again, no problem. Net charge works out nicely, a negative 1. So what do we have? Again, check 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Notice when you're counting electrons around an atom, you count the lone pairs, and you get to count all the bonds, and you get to count all the bonds to both atoms. Notice I count all the electrons to make sure I have 16, 2, 4, 6, 8, 10, 12, 14, 16. There you have it. It's a bit crowded. I hope it wasn't too hard to see. 3 solutions for the thiocyanate anion. If you got all 3, well done. You're exceptional. If you got 2, well done, you're doing very good. And if you've got 1, you're doing your homework and you're learning how to do Lewis structures. And if this was a Lewis structure question on the quiz, you'd probably be asked only to give 1 of them. The time you have to generate 3 will be coming up next, shortly in the lecture sections. You may be asking, which structure is the correct Lewis structure? Which structure is a real structure? And to answer that question, we have to get a little further on our organic chemistry lectures. So we're going to leave it here for now. Thank you very much.